Here's a video helping us with our arithmetic sequences with the recursive notation. So my recursive notation is named recursive because it is talking about your an and your an minus 1 terms. So right here you can see I have my an equals my an minus 1, and in this case it's plus 8. So the reason for this is it's called recursive because this guy is referring to his old term. To get my new term, I have to look at my old term and add that change. So in this case, it's a plus 8. So every single term, I'm going to be adding plus 8 plus 8. And we know that because this guy is my difference. So he's saying take my old term plus 8 is going to give me my new term. Now I do have to pay attention to this part. It says that a1 equals negative 17. Knowing my sequence notation, a1 has to be my first term. So that means that if I was going to list this out, I would have my first term is negative 17. Next term, I'm going to have to do what? Well, I should add 8 every single time. So plus 8. If you take negative 17 plus 8, you should get negative 9. Next term, again, I need to add 8. Every single time, I'm going to add 8 to get my new term. So I'm going to get negative 1 here. Let's do it one more time. Plus 8, I'll get 7. And maybe one more time. Plus 8, I should get 15. So my sequence is growing by 8, and you can see it'll continue going on here. My first term, a1, is this negative 17. This is kind of the common sense way to build my sequences. We can also always do it by just looking for a1, a2, a3. So a1, my first term, is already given. a1 was given right here as negative 17. So I know that's negative 17. So now I need to find a2. So if I wanted a2, I have to put a 2 into this guy. So now this becomes a 2, this becomes a 2. So a2 equals a2 minus 1 plus 8. 2 minus 1 is the same thing as a1. So now I have a2 equals a1 plus 8. a1 was already given to me as negative 17. So this becomes negative 17 plus 8. That's my a2. And that is going to be negative 9. So I did find that this next term is going to be negative 9. Now, I'm looking for a3, so I'm going to go ahead and look for a3. This guy now becomes 3, and this guy becomes 3. So I have a3 minus 1 plus 8 from this equation right here. Then, 3 minus 1 is 2. So that turns into a2. But I just found out what a2 was. a2 is this number. So now I put negative 9 here plus 8. And that's going to give me a3 equals negative 1. So now I have negative 1. And you can see that I'm growing the same way as before. I started with negative 17, negative 9, negative 1, and I'll continue growing by this plus 8 every single time. Hope that helps you with your arithmetic recursive examples.